So you can comment down below if you have not gotten the trigonometric identities, and you can always get them online. Now let's go to some proofs that we have here. For example, you can be asked to prove that sine square theta or x minus sine square x, this can be any angle, is equal to sine square x tan square x. Yes, so you can prove this by the left hand side or the right hand side. Now this is the left hand side, similarly this is the right hand side. Now how can I prove this? Now recall that we can express this part. Let's consider the left hand side now. If you recall that we talk about tan theta is equal to sine theta upon cos theta, right? Good. So if that's the case, we can actually express tan square x. We can express it as what? Sine square x all over cos square x, because of this identity, right? By the virtue of this identity, we can do that. Good. So if that's the case, we can take this to replace this part of the left hand side. Good. So our left hand side will now look like sine square x, right, upon cos square x minus, that's, we have replaced this guy with the identity, then we have sine square x, right? Good. So let's work with the left hand side. Let's make the left hand side look like this right hand side. So what we are trying to do in essence is that we want this part of this equation to be equal to this part of this equation, right? That's what we want. Good. So if that's what we want, all we need to do now is to find the LCM here, and the LCM here, unfortunately for us, is just cos square x, since this is 1. So cos square x into cos square s is 1. 1 multiplied by sine x here, we're going to get sine square x. Beautiful. So we have cos square x divided by 1, we're going to get cos square x. We multiply it by sine square x. Here we're going to get minus, let's extend it a little, minus sine square x, then cos square x. Good. Now that we have this, we can actually factor out. How can we factor out? Right? We can factor out this. Let's factor out sine x. Remember, we're just trying to make it look like tan square x and sine square x. So factoring out, we are going to have in the numerator, we can have sine square x into 1, then minus cos square x. That's fantastic, upon cos square x. So if you recall from our identity, one of the identity we have one of our identity here. Let me write it in another color. If you recall this identity here, we remember this identity, sine square x plus cos square x is equal to 1. Is equal to 1, right? We remember this identity. So instead of 1, let's replace it with this identity, right? That's the essence of proof. That's the essence of proof. So if that's the case, right now, instead of having to write 1, I will go ahead and write sine square x into, here we have sine square x plus cos square x, which is 1, then minus cos square x, right, upon cos square x. Now you can see that automatically these and these can cancel out, so we are left with sine square x here. We're left with sine square x. Then what is remaining here is another sine square x upon cos square x. And recall, sine square x, cos square x is the same thing as tan square of x. So if you look at this, now if you look at this, you will discover that this is actually equal to what we have, right? So this is actually equal to what we have here, sine square x and tan square x. Good. So by so doing, you are done with this particular example. So check out the next video for another example. The next video will have another fantastic example. Good luck.